Okay, so p hat and q hat. So p hat is x over n, so 20 over 36.556. You guys meet yourselves. And then q hat is just 1 minus that, so 0.444. Mute. And then b, find p bar and q bar when x1 is 18, n1 is 60, x2 is 20, n2 is 80. So my successes, my yeses, I have 18 plus 20 yeses out of 60 plus 80 people. So I have 36 over 140, which is 0.271. Q bar would be 1 minus P bar. So 1 minus 0.271, 0.729.
Professor, 18 plus 20 is 36.
Oh, shoot. So is this completely wrong? Is it not 271?
Well, the answer is good. It's 0.271.
Okay, so I just wrote the wrong number here. Okay, so I did it right in my calculator. I wrote it wrong here. Okay, thank you. Unfortunately, these notes are already done. I can't fix them, but thank you. Shoot. I'll try to fix them if I can go back into it later after class. So this is slide number 27. Slide 27. 38. Okay. Next. So the test statistic for the two proportions. So steps 2, 4, and 5 stay exactly the same. The only thing that changes is step 3. So step 3, my test stat kind of towards the bottom of your page is, and you can change the Z to test stat if you want, TS. It's what you observe from your sample, the difference in your sample, so P hat 1 minus P hat 2, minus what you expect the difference to be. So P1 minus P2. But remember, we expect P1 minus P2 to be 0. We expect there to be no difference. That's our null hypothesis. So this just crosses out and goes away because we expect the difference between the proportions to be nothing. That's what we expect according to the null hypothesis. So we kind of just ignore that part. So if you look at the bottom right part, it ignores that. And then the bottom is square root of, so it's the standard deviation for two populations. So you add their variances and square root that. So it's square root of P bar Q bar over N1 plus P bar Q bar over N2. But we've simplified that out over here. In your notes, it's been simplified where they've pulled out the P bar Q bar. So we put P bar Q bar times parentheses 1 over N1 plus 1 over N2. So that's what you have in your notes. If you look at your notes, it's a little bit clearer. And I think it's also here in your, right? It's also right here. You can see it right there. And it also gives you P bar, how to find P bar. X1 plus X2 over N1 plus N2. And then also, see where it says that X is not given, use X equals NP and round to the whole number. Right? 'Cause you can't have, 3.5 successes. You have to have a whole number of people. So this is all your stuff right here. It's really kind of cool. This is an excellent form that my friend Alan made. All right. So that is our test stat. And it's not different than the rest of it. It's exactly the same. I'm not pulling something strange on you. It's consistent with what we've had before. What you get from your sample minus what you're expecting from your claim divided by the standard error, the standard deviation for that. Okay. So let's do an example. Let's not do this as weird. Let's have someone read it. Hold on. So, Austin, have you read yet today, Austin?
I have not.
Oh, great. Go ahead and read for us.
Vaccination. In the nursing home study mentioned in the chapter opening statistics today, the researchers found that 12 out of 34 small nursing homes had a resident vaccination rate of less than 80%, while 17 out of 24 large nursing homes had a vaccination rate of less than 80%. At alpha equals 0.05, test the claim that there is no difference in the proportions of small and large nursing homes with a resident vaccination rate of less than 80%.
Perfect. Thank you so much. All right. So first, how to know if this is a mean or a proportion. Look for the word mean or average in here. There is no word mean or average in here. Average is another way to say mean. So that means it's most likely a proportion. Also, it says proportion right here. You might think that this 80% indicates something, but the thing is, this is not one of the numbers you're going to be using. This is the question that was asked. So it's a little bit misleading. Vaccination rate of less than 80%, and that's the question we asked people. We said, is your vaccination rate less than 80%, yes or no? So in a sense, the fact that the question was a yes-no question should tell you it's a proportion, but this 80% itself, it's not a number you're going to be using. It's just what the question was. So don't get confused by that. I know it's a little bit confusing. So what are the proportions is this 12 out of 34 small nursing homes. So 12 out of 34, that's a fraction, right? That's a proportion in disguise. And then we had 17 out of 24 large nursing homes. So those are going to be our proportions. And then we're claiming that there is no difference. So, whoops. Let me go back to my handy dandy sheet here. All right, so this 80%, ignore that because that's not a percentage. That's just the question that was asked. Those are not your proportions you're using. What you're going to be using is the small ones is 12 out of 34. So this is page 22, I believe. You should be filling this out because this is the page you're going to be handing in and scanning and turning into me. So your small ones, 12 out of 34. So your p-hat small is 12 out of 34.35. Your large ones is 17 out of 24. So your p-hat L, p-hat large, or p-hat 2 is 17 out of 24.71. So we are going to find, here it is down here, and we're going to find our p-bar. So it's going to be my successes. I had 12 plus 17 successes, 12 plus 17 successes out of a total of 34 plus 24 homes. So that's 29 out of 58, 50%. So my pooled proportion is 0.5, which means that my Q-bar is 1 minus that, also 0.5. So that's my P-bar and Q-bar, 0.5, 0.5. And then, what's my claim? Find the word claim. Test the claim. Here's my claim. Do you guys need a second? Are you guys okay if I keep going?
I do need a second, sorry.
Okay, take a second.
No difference in the proportion.
Right, that's my claim. My claim is no difference.
No difference.
Okay.
All right, so my claim is no difference. If there's no difference between them, that means they're equal. Everybody on board with that? Test the claim that there is no difference. And I would test the claim that they are equal, the proportions are equal. So my H naught, my claim is going to be that P1 equals P2. Everybody on board? Claim is no difference, so the proportions are equal. So my claim is going to be that P1 equals P2. So that makes H naught my claim, because H naught is always equals. Always, always, always equals H naught. So since my claim is equals, then my claim is H naught. And I'm going to be using the word reject. So you're going to write H naught is P1 equals P2. That's my claim. And in parentheses or somewhere around there, you're going to write the word reject, because that's the wording you're going to use in part 5. Whenever H naught's your claim, you use the word reject later on. H1, since H1 is not my claim, H1 becomes the opposite of my claim. So H1 becomes not equal to. So H1 is P1 is not equal to P2. And these are not the numbers. I'm not talking about p-hat. Let's be clear here. These are the proportions, the true proportion of all small nursing homes and all large nursing homes. I don't know those numbers. These are the things I don't know. I don't know, these are the population proportions. I don't know the whole population. I know the samples, the p-hats. And I'm going to use those in these numbers down here. But this is my theory, my hypothesis about all of them. So this is not p-hat 1 and p-hat 2. This is P1 and P2, which I don't know. All right, so you guys should be good with that part. Step 2, find the critical value. So I'm going to look it up. My alpha is 0.05. It's 2 tails. It's proportion, so I'm going to use the very bottom of the page. So alpha is 0.05, two-tailed test. This is my third column I'm going to use. Proportion all the way down to my z distribution. Remember, this bottom row is my z table, so it's 1.96. So positive, negative, 1.96. Those are my critical values. I'm going to shade. So shade off your tails, and then compute the test value. So p hat 1 minus p hat 2, 0.35 minus 0.71. This is always going to be 0, so you don't have to write that. You can just ignore it. That's fine. Divided by square root of p bar q bar times 1 over n1 plus 1 over n2. So let's calculate that. This is how you do it. Again, work from the inside out. So you're going to want to work from the smallest numbers to the largest numbers. So, smallest numbers. From the most inside outwards. So here, my square root is kind of inside, and then inside of that is this parentheses here. So you're going to want to work with this part here. Ignore what I said earlier. So you're going to want to work with this part here. 1 over 35, 1 divided by 34, plus 1 divided by 24. Enter. That's my parentheses. And then I work my way out from there to times 0.5 times 0.5 times 0.5 times 0.5. That's commutative, so I can just do those without doing anything else. And then I want to square root this. All right, so there's my answer. You need to square root it. Easiest way to square root it is to raise it to the 1/2 power. So I'm going to raise it with this little caret up. So raise it to the 0.5 power, the 1/2 power. So again, raise it to the 1/2 power, the 0.5 power. Enter. That's my denominator. 0.13330. Write that down somewhere. The top is going to be 0.35 minus 0.71. My top is negative 0.36. So I have negative 0.36 divided by 0.13330, and you get negative 2.70. So that's my test stat, negative 2.70. And I'm going to pop that right in where it goes. And if you're not sure where it goes, you can always make sure they have the same number of decimal places, and then just make them whole numbers. Negative 270 is to the left of negative 196, so it goes over here. And you can see it's totally in the rejection region. Right, so rejection region, so I'm totally going to reject H naught. Right, it's guilty. I have enough evidence in this guilty region. So step 4, reject H naught. That's all you have to write down is reject H naught. Why? Because I got something over here. You guys take a look. H naught says that I am right here. H naught says that you are here. If I get something in this range, then sure, maybe that's true. Maybe my H naught is right here if I get something in here. But if I get something way out here, then my mean, my H naught or my proportion is not here. It's got to be something further to the left. Right? So because I got something way out here, I'm going to reject H naught and say that I am not here. I've got to be something closer to this direction over here because I've got something way, way, way out here. If I've got something in here, then sure, H naught might be true. But if you get something out here, then or over here, then you're going to reject H naught and say it must be something else, something further this way or further that way. So because I rejected H naught, then I do have enough evidence. There is enough evidence to, and again, my claim was H naught. So because my claim was H naught, I use the word reject here because rejecting H naught rejects my claim because my claim was H naught. So there is enough evidence to reject the claim that there's no difference in the proportions of small and large nursing homes with resident vaccination rates of less than 80%. Okay, so you guys go ahead and do, I'm going to have you guys read it first. Okay, so I'll give you guys in 30 seconds to write this down. 15 seconds, maybe. Are there any questions? All right, I'll put this back up in a minute, but we're going to go ahead and start in on summer reading the lab problem 2. So, Janessa, have you read yet today? Can you read this one?
No, I haven't.
Great, thanks.
A survey of 200 randomly selected male and female workers, 100 in each group, found that 7% of the male workers said that they worked more than 5 days per week, while 11% of the female workers said that they worked more than 5 days per week. At A equals 0.01, can it be concluded that the percentage of males who work more 5 days per week is less than the percentage of female workers who work more than 5 days per week?
Great, thank you. All right, so again, we're looking at this one. So 200 people are selected, random selected. So this is my survey, right? Survey. This is going to be my sample part here. But there's 100 in each group, so that means that my N for the males, there's 100 males, and it means that there's 100 females. This 5 days per week, that is not one of my numbers. So this is not a mean with a number of 5. This is worked more than 5 days a week. This is my question. Did you work more than 5 days a week? Yes or no? That's a proportion. Also, how else do you know it's a proportion? There is no word mean or average in here. If you look through this whole thing, you will not find the word mean or average anywhere in here. It's a proportion. Also, you'll find a percentage. This is a percentage. So we have 7% of males, 11% of females. Remember, I always have to give you either the number of yeses, so the number of workers who said yes, or the percent of people who said yes. So this right here, is this the number of workers who said yes, or the percent who said yes? Which one is it, guys? Percent, exactly. This is the percent. So you do not put this number over 100. This is P hat. I've just said, here's P hat. Boom, right there, take it. 7%. P hat is 0.07. So you're given the percentage. You do not put it over 100 because this is not X. Now you need to find X. Remember, X is equal to NP. So you're gonna have to calculate X on your own, because I didn't give you X, and you're going to need X later on to find your P bar and your Q bar. So if using this, I have my N, I have my P, you can find the X that goes with it. Just multiply 100 times 7%. Okay, so I think you guys are good to go. You're concluding that the percentage of males who work blah, 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 the percentage of males is less than the percentage of females. All right, so go ahead and hop into your groups, and we will come back to this in a little bit. All right, so let's go ahead and take a look at this. We'll go over it. All right, so here we have 100 male workers, 100 female workers, and we're ignoring the 5 days per week because that's just confusing things, right? And we're concluding the percentage of males is less than the percentage of females. So our claim is that P1, the males, is less than P2. That's our claim. All right, so then first we got to find P1. I gave it to 7%. You also got P hat 1, 7%. P hat 2, 11%, because this is from the survey. This is from the sample. You guys see this sample, so that's where this is coming from. So that's your P hat. And then your P bar is going to be 7 plus 11 over 100 plus 100, because we had 7 min. 7% of 100 is X is N times P. 100 times 0.07, right? 100 min, 7%. That's 7 min plus 11 women. Again, 11% of 100 is 11. and there's a total of 200 people, 100 men and 100 women. So you have P bar is 0.09, which means that Q bar is 0.91. Okay, so our claim is that P1 is less than P2, men work less than women, H0 is always equals, H0 is equals, so H0 is that P1 equals P2. So since that is not our claim, then H1 has to become our claim. H1 becomes P1 is less than P2. That's our claim. Since H1 is my claim, I'm going to use the word support, because whenever H1 is my claim, I use the word support. Whenever H0 is my claim, I use the word reject, like we did last time. But here, H1 is my claim, so I'm going to use the word support. And then, I bust out my handy-dandy T-table. Alpha is 0.01. This is one-tailed, left-tailed. So alpha is 0.05, one-tailed. It's going to be the second row here. And I'm going to go down, and it should be alpha is 0.01, one-tailed. It should be 2.33, or 2.327. Oops. I'm in the wrong spot. Oh, no. No! I don't even know how to get out of this. I'm not even sure what I did. Okay, close that. All right, great. So it's on my picture. Critical value is negative because it's left tail, less than. It should be negative 2.33 or negative 2327 sign. Shade to the left because that's my rejection region. I'm going to do my test stat. So p hat 1, 0.07 minus p hat 2, 0.11, divided by square root of p bar q bar, 0.09 times 0.91, times parentheses n1 plus n2, 100 plus 100. So you find that, right, again, we're inside out. So 100, 1 over 100 plus 1 over 100 times 0.09 times 0.91, and then square root that. You get 0.0405. Do the top part, 0.07 minus 0.11, negative 0.04. Divide those, you get negative 0.989. So then you pop that in here, or is it 988, I guess it is. And this is clearly in the do not reject region. It's in the white region, the clear region. So this is do not reject H0. Everybody on board with this being the do not reject? So because I did not reject H0, then I do not have enough evidence. Those two things go together. Right? So if I do not reject H0 in step 4, then I do not have enough evidence in step 5. Those match up. Good? Got it? Okay. So I do not have enough evidence. And you can see that here because I'm in the do not reject region. I do not have enough evidence. To support. So support, again, comes from this word up here in my step 1. That's the same word that's going to be right down here in step 5. To support the claim that men work less overtime than women. Or something along those lines.
Professor?
Yes.
I have one question. How minus 2.33 come? CV?
Because it's left tailed, so it has to be negative.
Yeah, but which value do you use? I know.
It's a proportion. So if it's a proportion, then you're going to use the bottom row.
Okay.
So the very bottom row, alpha is 0.01, you're going to use 2.327 down here. Do you see it down here at the bottom of my page? Ujwala? Ujwala, look.
Yes.
Yeah.
2.327,
yes. Yep.
At the bottom.
Yep.
Infinity.
Yes. Because it's a proportion. Proportions, you use the infinity.
Okay. Understood. Thank you.
Okay. So, good. Now the next page, page 23, we're going to skip that page. We do not have enough time. We've got too many other things going on. This other stuff is taking, we got too many things going on semester. So that I can skip. I did cover it in the sense that I told you what it is. Here's the confidence interval, there's the formula, there you go, we covered it, fine. We're skipping page 23. Let's draw a line through that, or an X through that, and we'll move on to page 24. So this is page 24. We're talking about testing difference between two means. I think it says two population means, independent samples, 9.3 is what your sheet says. So first of all, both samples have to be random. They have to be independent of each other. In other words, there can't be a relationship between the two samples. And then sample sizes have to be at least 30 or normally distributed. Okay. Now, your sheet is going to look like this. And H naught, you should write that in somewhere, is that it's always equals, right? H naught is always equals. In this case, mu1 equals mu2. So that's your H naught. It's going to follow a T distribution, right? Mean Mr. T. And I'm going to give you these, you're going to have these items. So you have mu1, which is the population mean. And then your sample will also have S1, X bar 1, sample mean, and N1, the sample size. So every sample is going to have a mu, an X bar, an S, and an N. You'll have one for sample 1, you'll have another one for sample 2. The numbers, you guys quiet, the numbers are going to be, I'll give you the numbers for X bar, S, and N. Mu, we don't have the number for it because that's what we don't know. So the mu, that's going to be just in our hypothesis, but we don't know it. These ones I always have to give you. You're always going to get the X bar, the S, and the N. Always, 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 always. All right. So here's our test stat. And again, remember, mu1 equals mu2. So when you subtract them, this should be 0. That goes away. So you just get this. X bar 1 minus X bar 2 over the square root of S1 squared over N1 plus S2 squared over N2, because you add the variances and you square root them to find the standard deviation. So this is where this part comes from. And the degrees of freedom is going to be the smaller of the n's minus 1. We're just going to simplify it. This book just simplifies it and makes it kind of straightforward. Just use a smaller n minus 1. That's good enough, and that's what your book uses. So we're going to go with that. So, again, here's the formula. I kind of went over with you in the last sheet anyway, so we're good there. So here's an example. Gina, go ahead and read for us.
Researchers conducted trials to investigate the effects of color on creativity. Students with a red background were asked to think of creative uses for a brick. Other subjects with a blue background were given the same task. Responses were given by a panel of judges. Researchers make the claim that blue enhances performance on a creative task. Test the claim using a 0.05 significance level.
Perfect. So we have two groups. We have people who are put in a red room and people who are put in a blue room. So the red group, they're first, I'm just going to call them 1. You can switch this around, it doesn't really matter, but it's just easier to take the first one, call it 1, the second one, call it 2. So I have my N1, X bar 1, and my S1 for my reds, and for the blue ones, it's my group 2, so this is going to be my N2, my X bar 2, and my S2 down here. And we're claiming that blue enhances performance. So in other words, the blue should have a higher score. So blue is going to be greater than red. In other words, 2 will be greater than 1, 1 will be less than 2. That's going to be my claim, is that the 1 is smaller than the second one. The red is smaller than the second one. So here's my claim. Red is less than blue. In other words, group 1 is going to be less than group 2. So my H naught always, always, always equals mu1 equals mu2. Or if you want, you can put R and B. Mu R equals mu B. That's fine too. I don't care. Those are just labels. You can call them R and B if you like. You can call them 1 and 2 if you like. Doesn't matter. So the H1 will be that then that mu1 is less than mu2, or mu-r is less than mu-b, depending on how you want to label them. You guys are filling out these notes in your page 24. That's step 1. Step 2, find the critical value. Sigma level is alpha is 0.05. It's actually incorrect, I think. But I used the t-table to look it up. This should actually be 0.025. I don't think it'll put that in there. 0.025. So if we kind of look at our table, the one-tailed test, and it should be 0.025. I made a typo there. So 0.025, and it's 34 people or 35 people. So degrees of freedom. Let me see if I can get back to here. I think we did it. I think I did it here. Nope, I didn't. So 34 is my degrees of freedom. So if I look on here, if we go down, you'll see that there is no 34. There's just a 30 and a 40. You guys all see that? There's only a 30 and a 40. There's no 34. So you always have to round down. Take the, because I don't have enough for 40, so I'm going to round down to 30. So I'm going to grab this one, 2.042. That's going to be my critical value. And again, we're going to, I made a typo. This really should have been alpha is 0.025. Something changed along the way, but your alpha should be 0.025. And so because it's left-tailed, your critical value is going to be negative 0.024, negative 2.042. I can't talk. So here's my picture. Critical value, negative 2.042. So why is it 0.025? Because I made a typo, Ujwala. It's just a typo. So it's my mistake. And so then when you put these in, you're going to find your test stat. So X bar 1 was 3.39, X bar 2 was 3.97, and then my S1 was 0.097, and then my N1 was 35, my S2 was 0.63, my N2 was 36. So if you calculate these, again, I would say work from the inside out. So you're going to want to work from the lowest spot to the largest spot. I need to move this up a little bit, sorry. Okay, so I've got, let's start from the inside here. So the great thing is that you can actually, because of how order of operations work, you can just put all those in at one time. So 0.97 squared, oh, sorry, quit out of that. Can you guys see that okay? I'll move it over here. 0.977 squared divided by 35 plus 0.63 squared divided by 36. Enter. I can just pop that part in, and I'll get 0.0379, and I want to square root it. So I'm going to raise it to the 1/2 power. So raise it to the 0.5 power, and that's my bottom. 0.1947 on the bottom. The top is going to be 3.39 minus 3.97. So the top is negative 0.58. Can you guys all see that okay? Is this in the okay spot? Yes, no? Hopefully.
Yes.
Okay.
Yeah.
Okay, good. All right. So, all right. And then I'm going to divide those two. So I'm going to take this and I'm going to divide by what I had in the beginning, 0.1947, and I get negative 2.979. Great. So that is our answer. Negative 2.979. That's our test stat. Pop that in. And clearly that's in our rejection region. So we're going to reject H naught, which means that we do have sufficient evidence. We rejected H naught, so we have enough evidence to support the claim, because remember H1 was my claim, so we're going to use the word support here. The claim that the red background group has a lower mean creativity score than the blue background group. So I'll give you guys a minute to write that down. And again, I made a mistake. This should have been an alpha level 0.025 because I grabbed the wrong critical value. Or, you could say I grabbed the wrong critical value. Either way, it's still going to be a reject there. Let's take a minute, write that down. Yeah, I think on the notes I'll just fix that because really the critical value should have been from here. It should have been 1.697. Okay. All right. Now, the last thing I want to talk about before we go, hopefully you guys have had a chance to write this down, or at least sufficient evidence to support the claim. You can just copy the rest of it later. Is Lab 5. So all I need from you guys, you do not need to print out stuff because you already have this file that I gave you guys, the handout I gave you for Lab 5 long ago. I just need you to fill out the last 2 pages and scan those, and then send me the actual Excel or Google Sheet file that you have. So do the stuff in your file, send me the actual file, or a link to the file, and I'll find that stuff myself, and then give me the scans of the last 2 pages. So how does that look? So these last 2 pages, let me see if I can find the whole, I don't have it here. Okay, so there's, if you go to the Lab 5, the last 2 pages, pages 5 and 6, look like this. These are the 2 I need printed and filled out. So here it talks about, let me get this out of my way. Okay, so here it talks about, you find the IQR, you guys remember how to find that, Q3 minus Q1, and then multiply it by 1.5. So you find 1.5 IQRs, and that's how much you're going to jump to find your cutoff. So remember, the outlier cutoff is going to be 1.5 IQRs below Q1, so you're going to take Q1 and subtract this amount, and then it's above 1.5 IQRs above Q3, so you're going to take this amount and you're going to add it to Q3 to find out your cutoff on the top, and then write down any outliers you have. So say you had an age of 71, someone was 71 years old, that's an outlier. It's because your cutoff is probably going to be like 40 or something like that. So you'd write in whatever your outliers are here, list them, anything you have. If you have more than like 6 outliers, then just say, just list the first 6, that's fine. And then you're going to have a part also where you, really I don't have this printed. Here it is. So all these parts, you're just going to, finding your average, finding your median, finding your mode, your standard deviations, your quartile, Q1 and your Q3. Those ones you're just going to do on your sheet. You also need to do a histogram somewhere in there. And you don't have to worry about printing it, so don't even worry about this whole page here about the printing, because I am going to look at your file instead. So don't sweat that part. It's just these pages down here. And then you're going to fill out these pages too. So you need to figure out what is within one standard deviation. So write in your lower upper bounds for 1 and 2 and 3 standard deviations, right? So you have your mean, you're going to subtract a standard deviation, put it here, add a standard deviation, put it there. And then you need to figure out how many of your data values lie within 2 standard deviations. So physically, from this number to this number, count out how many of them are in there, and you can use that count function for that if you want. And then for 3 standard deviations also, say whether that agrees with Chebyshev's, and then do the same thing with empirical rule. You have to include how many fall within 1 standard deviation and what percent that is, and whether that matches up with what you think the empirical rule is, and based upon that, whether you think your data is normal or not. So you can say whether you think that they are and then look at your mean and median. If they're close, see if they're about the same, or if one's greater or higher, so whether your data might be based upon that normal or right skewed or left skewed. And then look at your histogram and say whether you think your data is normal, left skewed, or right skewed, or something else. All right, that's it. Have a great weekend. I will talk to you guys later. Take care. Thanks for hanging in there.